grade 9s, I wanted to make a video just to take up the solutions for this mini assignment about finding the equation from a table and a graph. Now, often the first thing that we would look for here was the independent and dependent variables. Now remember, the independent variable is the thing you choose and the dependent variable is the thing you calculate. And the independent variable is always on the left of the column and the dependent variable is always on the right hand column. So my independent variable is the number of people, and I'm going to use n for number of people, and the dependent variable is the cost, and I'll use a letter C for cost in my equation. Now the next thing we need to do is find, I think I'll do rate of change, and we'll figure out what the rise and the run are, and then figure out what the rate of change means here. So remember that you can choose any two pairs as long as you choose the same numbers from the same row for the rise and for the run. So I think I'm going to choose these ones. So I'll do rise is 675 minus 275, a little squished in there, but I get a rise of 400. And then I'll choose run. I have to choose the same ones that match up right across from the ones I chose for rise. So my run is 60 minus 20, which is 40. Then I know the rate of change is rise over run, which is 400 over 40, which is 10. And remember that the units of rate of change is always the rise units, which is dollars, over the run units, which is per people. So it's $10 per person. So I'm just going to fill in my answers here. Rise is 400, run was 40. You may have different numbers there, but you should have something that will equal the same rate of change. So you might have had 220 or 660 for your rise and your run. So I'm just going to do 400 over 40 equals 10 for my rate of change. And what does the rate of change mean? In this situation, we want to look at what the units are. That can usually give you a good clue. So it's $10 per person. So this is the price per person. Didn't all show up there. Price per person for this banquet. Now, we're going to have to figure out the initial value. And remember that the initial value, we had to pattern back and figure out where it would have been equal to 0. Because I don't have a 0 in this column, but I can follow the pattern. 80 to 60, 60 to 40, 40 to 20. I see I'm going down by 20 each time. So the next one above, if I added another column or another row up on top, would be 0. And then I look at how much it's decreasing by here. 875 to 675, then 675 to 475, 475 to 275. So I see I'm going down by $200 each time. So if I decrease this one by 200, I get 75. And then that is my initial. So my initial value is $75. And that would be the base fee for the banquet. So maybe it costs $75 to rent the hall and then $10 per person for the food or whatever you've got there. Okay. So remember that your equation is always your dependent variable equals your initial plus or minus the rate of change times your independent variable. So now I'm going to use all of those pieces that I found. My dependent variable was cost equals the initial is 75. Then I have to choose, is it going up or down? You choose which one, plus or minus. And obviously I see that those costs are increasing with each person. It's going to cost more as the number of people increases. The rate of change was 10. And my independent variable was n for number of people. So the cost of the banquet is $75 plus 10 times the number of people. kind of a similar situation here. So here, remember that your independent variable is always on your x-axis or your horizontal. So I'll say my independent variable is time, and I'll use a t to represent time. And, oh, this actually, you know what? I have a bit of a weird situation here because I have temperature for my other one. So I might make my independent variable m for minutes. Because my dependent variable, I'm going to use T for temperature. So after m minutes is my time. I don't want to use T for both. That would get really confusing. Okay, then I'm going to, the initial is pretty easy to find from the graphs. So my initial is 25. So I'll put that in my chart here. And what does the initial value mean in this situation? So here the initial value means the starting temperature. The 25 degrees is on that vertical axis that's measuring temperature, and it's the very start. So then I'm going to look at my rate of change. Now remember, when you're calculating rate of change, you want to be sure to pick numbers that are on a corner. I wouldn't want to, for instance, pick that point because I don't know what it is. It's somewhere in between 30 and 35. I don't want to use a point where I have to estimate. So I'm going to pick one maybe like right there. And then I'll like look along that line and find another one where it's like a nice even point. So I'll choose those 2 points. And then make my rate triangle and figure out my rise and my run. So the rise here, I'm starting at 30 and going up to 40. So this rise, how far up did it go? 40 minus 30. So it went up by 10 degrees. And then the run, here we want to look at the time left to right. So I started at 2 minutes and it ends at 6 minutes. So I went over by 4 minutes. So the run is 6 minus 2, which is 4. And then my rate of change is always rise over run, which is 10 over 4. And here that's 2.5. And now we want to think about what the units are, because that can tell us what it is. So it's always the units of the dependent variable per units of the independent variable. Because rise is on top, that's the dependent variable. So that's degrees Celsius per minute. So it's going up 2.5 degrees Celsius per minute. This maybe is something that's getting heated up. So my rate of change is 10 over 4, which is 2.5. And what does the rate of change mean? It's the increase in temperature per minute. So that's how fast the temperature is increasing. It's going up by 2.5 degrees every minute. Remember, I'm always using dependent variable equals initial plus or minus the rate of change times the independent variable. So then I just want to put in all of the things that I've found. My dependent variable is T for temperature equals the initial, which was 25, plus or minus. This line is going up, so I'll put a plus. It's going up in temperature. The rate of change is 2.5. And the independent variable is m for how many minutes. And that's your equation. So that's how you do both of those. Please make sure to check your answers if you didn't get full marks.